Global warming. Global warming is a term used for the observed century-scale rise in the average temperature of the Earth's climate system, and its related effects. Scientists are more than 95% certain that nearly all of global warming is caused by increasing concentrations of greenhouse gases, GHGs, and other human-caused emissions. Within the Earth's atmosphere, accumulating greenhouse gases like water vapor, carbon dioxide, methane, nitrous oxide, and ozone are the gases within the atmosphere that absorb and emit heat radiation. Increasing or decreasing amounts of greenhouse gases within the atmosphere act to either hold in or release more of the heat from the sun. 10 Climate effects. EPA.png. Our atmosphere is getting hotter, more turbulent, and more unpredictable because of the boiling and churning effect caused by the heat-trapping greenhouse gases within the upper layers of our atmosphere. With each increase of carbon, methane, or other greenhouse gas levels in the atmosphere, our local weather and global climate is further agitated, heated, and boiled. Global warming is gauged by the increase in the average global temperature of the Earth. Along with our currently increasing average global temperature, some parts of the Earth may actually get colder while other parts get warmer, hence the idea of average global temperature. Greenhouse gas-caused atmospheric heating and agitation also increase the unpredictability of the weather and climate, and dramatically increase the severity, scale, and frequency of storms, droughts, wildfires, and extreme temperatures. Global warming can reach levels of irreversibility, and increasing levels of global warming can eventually reach an extinction level where humanity and all life on Earth will end. In this book, irreversible global warming is defined as a continuum of increasing temperature that causes the global climate to rapidly change until those higher temperatures becomes irreversible on practical human time scales. The eventual temperature range associated with triggering and marking the beginning of the irreversible global warming processes is an increase in average global temperature of 2.2 to 4 degrees Celsius, 4 to 7.2 degrees Fahrenheit, above pre-industrial levels. Extinction-level global warming is defined in this book as temperatures exceeding pre-industrial levels by 5 to 6 degrees Celsius, 9 to 10.8 degrees Fahrenheit, or the extinction of all planetary life, or the eventual loss of our atmosphere. If our atmosphere is also lost, this is referred to as runaway global warming. The result would be similar to what is thought to have happened to Venus 4 billion years ago, resulting in a carbon-rich atmosphere and minimum surface temperatures of 462 degrees Celsius. The temperature levels described above for irreversible and extinction-level global warming are not hard and rigid boundaries, but boundary ranges that describe the related consequences and their intensities within a certain level of global warming. These temperature boundary levels may be modified by future research. More about irreversible global warming and extinction-level global warming can come about because of complex interactions that will be explained fully in Chapter 4. Chapter 4 and Chapter 5 will set the foundation necessary to understand how we are already creating the conditions that will precipitate irreversible and extinction-level global warming if we keep going as we are now. Carbon dioxide is currently the most important greenhouse gas related to global warming. For the longest time, our scientists believed that once in the atmosphere, carbon dioxide remains there for about 100 years. New research shows that is not true. 75% of that carbon will not disappear for thousands of years. The other 25% stays forever. We are creating a serious global warming crisis that will last far longer than we ever thought possible.